industrialization occurred. And different people have different ways of describing what made industrialization possible. Here are the three I like to work with. One is very important, is a reorganization in the way productive work was done. Prior to the Industrial Revolution, most productive work was done in the household, almost all of it. The household was the unit of production, and then there was this new way of organizing people to do work, the factory system. People went to work in a factory. There was also the subdivision of productive work. If you want to convert grain to bread, there are a lot of individual tasks along the way. One of them is grinding the grain. And so you saw those images of crude grinding with a stone and then the development of a quern. And each of those tasks, people figured out ways to mechanize them and then improve the mechanization. And then the third one is the application of non-human forms of energy to productive work, especially the chemical energy stored in the form of fossil fuels. This is what made the Industrial Revolution truly revolutionary. Those first two were already happening before people figured out how to use fossil fuels, and they would have continued to happen, but they would have been limited by the amount of energy they could have extracted from the environment, given the limits of plant photosynthesis and so on. Fossil fuels stripped away those limits, or so it seemed. And here's how Seiferle describes that. This transition occurred mainly in England. Coal had been known in England since 2,000 years ago during the Roman period. Coal was known in China as well for at least 2,000 years. People knew it burned. But no one made very extensive use of this strange mineral until about the 1500s in England. People started using coal to heat, especially in London, to heat their homes and for cooking because they couldn't get enough firewood to supply England. And then things took off. And this shows 1700. By 1700, people were using a lot of coal for making beer, for making glass, and by mid-century, they'd figured out how to make coal into coke, which is a metallurgical fuel. So they could make steel, or iron and steel, and not need charcoal. About 1800 is when steam power kicked in, and steam power took off after that. So look at the way the land use in England was divided. Initially, or about the time coal was used, the British were using virtually all the land on that island for what its optimal use was, whether it's cultivated fields or pasture land or woods, parks for supplying firewood. And so you can see those percentages. About 30% of the land was cultivated. A combined total of about 40% was forest land. By 1800, when the Brits were using a lot of coal, look what happened to forest land. It was about cut in half, down to 20%. And virtually all of that land that had once been forest land was converted to pasture. Not land for more human food, but pasture. And then with steam power, forest land was reduced again. Pasture land reduced a little bit because they didn't need animals for all the transportation. They had railroads, steam-powered railroads, and there's a significant increase in land use for producing food for humans. What Seiferle does is draw comparisons between the energy in a cubic foot of coal and wood, and you can see those comparisons, and with that, he's able to look at these equivalents between the coal being used on Britain and on that island and what it would have required had the Brits been deriving that energy, that fuel, from wood. And remember, when they were deriving that energy from wood, they were using sustainable forestry practices. They were doing this in a way that they could harvest that wood generation after generation.